So let me just show you how this ends up happening. So this is what happens, for example, when you're trying to see something that's far away. Okay, this is going to be more what's called sympathetic activation. So here's your thing that you're seeing. It's coming in. The lens is going to be basically flat. All right? You don't have to do a whole lot of focusing. So it gets refracted, and then your focal point is back here posteriorly on the eye. So that's why they call this the focal point. Okay, so this is your distance vision. All right? So when stuff gets closer, then you have to be able to adjust what's happening with that lens so that you're not like, seeing it all blurry when it comes up close. So now you're going to have to do the different changes. So what happens is that now your lens is going to change, and then they want to put that focal point where it's supposed to be, but you can move it based upon what your lens is doing. As you get older, you get this thing that's called presbyopia, right? I want you guys to know that definition, because this is what happens when these little muscles start getting weaker, and then they can't accommodate and shape the lens the way it's supposed to be. So then you start having difficulty either seeing up close or seeing far away, all right? Some individuals, you'll notice that everybody holds it out here because they can see it better out here because you can't focus here, all right? So that's why a lot of adults, as they start getting older, these tend to hold this stuff out there. I always joke with my mom, I run across the room. Can you see it now, Mom? She's like, shut up. So you're going to have also this pupillary reflex as well that then adjusts for the amount of light that comes in.
So what is
Presbyopia just means that your muscles, the ciliary muscles, they start losing their ability to focus and then bend the lens the way you want it to go. So when you have a parasympathetic, this is when it's closer or when you're relaxed, okay, obviously the lens here is going to be a little more, it's not going to be pulled as tight and flat, it's going to be more relaxed, so then you actually are able to bring things closer in. Okay, so it kind of bulges a little bit more. This next word, myopia, and then hyperopia, I want you guys to know those two. Myopia means nearsightedness, hyperopia means farsightedness. So what happens when you're nearsighted is that it will be corrected with a concave lens, because what happens with myopia is that now where your focal point is, it's too far forward. With hyperopia, it's too far back. So what they do is they make a convex lens. So what you're doing is you're actually taking the lens, and with the glasses, you're able to do this or this, and actually artificially adjust for that distance. And then astigmatism, that is when you have weird curvatures on the eye, and then you have to be able to focus everything in on one particular point. So this is what normal eyeball looks like. Okay, this is called emmetropic. Okay, an emmetropic eye is normal. So here are your parallel rays coming in. Here's your lens nice and flat. Focal point is exactly where it's supposed to be in the back of the eye. So here you have good vision. This is your 20/20. Myopic, this is when the focal point is too far forward. So what you need to do is you need to push the focal point back. How do you do that? You take your lens and you curve it like this. Okay, so you're actually bringing it back.
Wait a second.
Okay? So now what they did is they took that lens here, and then they were able to adjust it and then focus the points back here. So what you're doing is you're bending the light in a certain way so that it can work with what you've got. Right? You can't be without a lens, really. And then here's your hyperopic eye. This is when you have farsightedness.
And that's when you can see far, correct?
Yeah.
You can see
So
far.
here you can see far really well, but you can't see short.
Short.
Okay, when near is kind of hard, but far is okay. So now what you did here is now you've actually changed that lens and you made it more convex, okay? And so now they pulled the rays out more, and then that allows it to come in. So that's pretty much what they're able to do. So it has to do with the shape of the eyeball, or it has to do with what those little muscles on the eye are doing. So that's how you're able to adjust for all that. So I want to make sure that you guys know what these definitions are. Okay. Astigmatism, well, with astigmatism, you'd have the shape here in the eyeball is kind of like this. So what happens is it's going to be harder because now you've got the light coming in different ways. So what you need are lenses that can actually focus it and get those rays closer together. You can actually see them. So now you know what the big words for nearsighted and farsighted are. All right, then your rods and your cones, remember those are your photoreceptors. All right, and then when you zoom in, this is what you would end up seeing. So these guys here, these are the cells that are located in the pigmented region of the retina. This is the photoreceptor neural section. These are your rods, these are your cones. Of course, you know they're not purple and yellow in your body. So how they work is that they're going to be very sensitive to dim light. Okay, so sensitive means that they're going to receive that stimulus and be able to respond very well for that. Okay, so the input comes in, and it's going to be primarily in gray tones. So like what you're looking at here with the black countertop, that is technically a gray tone. It just happens to be a very dark type gray tone. The cones, these are going to be your bright lights. Okay, so when you guys walk outside, it's very bright out there. Your cones will instantly be stimulated. Your rods will downplay what they were doing, and then they will allow that light to come in. What you need to do is you need to be able to adjust for that. So your cones can do that pretty quickly. You're better off wearing sunglasses. You're in Arizona, Florida, any place that it's really bright. Okay, I wear them even in Minnesota, I don't care. I always wear them because they do help protect your eyes. But what's going to happen is the light comes in and then it's going to activate that. So when your cones get excited, okay, it's very similar to what happens with rods, and the light gets absorbed. So it'll either be cones that are more sensitive to blues, greens, reds. So it just depends on what the wavelength is of what you're seeing, right? And how well you can see and your acuity to see has to do with how active your cones are. Okay, some of you are going to have color blindness, which means that you don't have some of the cones. Not a big deal, right? If you can't match your clothes, just go to American Eagle or the Gap. They do it for you. Look at the mannequins, you're good to go. That's all I ever do. It's just easier, isn't it? All right. Then the signal transmission, remember EPSPs and IPSPs?
Oh, yeah.
All right? All this stuff has to
Easy to
do with the
easy
gradient
way.
potentials. So this determines how many cones are going to activate, how many rods are going to activate. And so it has to do with how much light is coming in. So then your eyes will respond and then you will adjust accordingly. Okay? And then the light will come in, and what it does is that it's coming in, it's going to hyperpolarize certain receptors that are going to cause it to stop releasing inhibitory neurotransmitters. So in this case, glutamate happens to be an inhibitory transmitter in the eye. All right, and then what happens is now the bipolar cells can respond, and then they allow the release of the neurotransmitter onto the ganglion cells. So this is basically how it works. So here are your rods. All right, so you have your little rod coming in. This little guy here, they're going to depolarize. So then they're going to send the signal here to your bipolar cell. These guys then get hyperpolarized, and then down here, there's no more signal coming in. All right, so this is how the rod stops working. Because the ganglion down here, this is where the optic nerve is. All right, if you don't stimulate the ganglion cell, nothing's ever going to get down here. So what you end up doing is then you end up hyperpolarizing down here, and then there's no depolarization at this end. So it just has to do with, did you activate or did you not activate? That's what it comes down to, right? You guys don't have to worry about all the entire physiology pathway. I'm not going to worry about that because you'll never see this again, okay, unless you become an ophthalmologist. But what I want to make sure you guys understand is that the rods and the cones are the things that are going to dictate, based on the light coming in, whether the signal is going to make it down here to the bottom and hit the optic nerve. All right? If it's really bright out, it's going to hyperpolarize the rods because you don't need them. If it's really dark, then you hyperpolarize the cones because you don't need them. So here's your receptor. When it's light out, okay, now the signal is going to be coming in, and then it's going to allow for that receptor to be, I should say, in the dark. Yeah, I should say in the dark.
The one before was.
Yeah. Yeah. Main thing you guys remember, rods are your dim light, colors are your bright light, and your colors. Okay. Then in terms of how your light adapts, okay, your cones and your neurons are going to adapt very rapidly. When it's bright out, okay, your pupils are going to constrict, allow less light in, but at the same time, the cones and the neurons are going to kick in because now they know, oh, we got more light coming in, but it's really bright out. So you kick in the ones that you need, and then your pupil will constrict, right, so that you don't end up blinding yourself. This is why when you look up at a really bright light, you end up kind of seeing spots after a while. It's because you have all these, it's almost like the cone's gone wild. They're trying to do their job, but they don't know quite where. Right? Yeah. So what you want to do is you want to make sure you're only activating the ones that you need. And this is why it's important that here in Arizona, because it's so bright out, you guys, make sure you wear sunglasses. All right, and try not to drive too much into the sun.
It's like a camera flash too, right?
Yeah. All right, then your dark adaptation, obviously this has to do with your cones, okay, and then they will adapt and then activate the rods.
Oh, sorry,
All right.
really quick, isn't it very important for reflections, or just the light in general?
Well, light and reflection causes problems. If you're out on the ocean and you don't have sunglasses on, you need to have that, because that light is really intense.
Especially if it's polarized, right?
Yeah. Well, polarizer are going to protect you more from the UV light too. Oops. Okay, all right, so in terms of your visual pathway, you are going to have synapses that are going to stop along the way. If you guys remember, I pointed out the optic chiasma yesterday when we talked about the optic nerve. That's where one of the decussations takes place. And then it's also going to go to the thalamus, and then part of it will travel down through the midbrain, and then, because remember, optic nerve number 2 comes off the midbrain, and then it'll synapse posteriorly. So I'm going to show you the pathway in a second. But I just want to make sure that you realize too that it'll go through this region called the superior colliculi. Those are the two little nubbies in the back of the midbrain that then synapse posteriorly with the cerebellum. And so then that's part of what allows you then to maintain your balance so you can actually see. And you guys remember the other day when I had you stand up, close your eyes, and then balance on one foot, it was a lot harder to balance yourselves because you lost that sensory aspect of the light coming in. But if you can see where you are, it's going to be much easier to balance. Right? One easy way to increase intensity when you're working out, you're trying to do your core balancing stuff, close your eyes. Right? That'll make it even harder. Okay? And make those muscles work more, especially your core one.
When you're doing what?
Any kind of core planks or side planks or
Close your eyes.
close your eyes.
We're gonna see if I can running around with blindfolds on.
Well, no, don't do that. You're sitting still. Okay? All right, then this is where they go. I'm just going to show you where it goes. Okay, so this is your vision right here. Okay, pretty wide range. So the light comes in, all right, little synapse and these little receptors, and then you're going to get some synapse coming back to the same side of the brain, and then others are going to go to the opposite side. All right, so these are going to be the tracks that go here. Right in this region, this is where the thalamus and the colliculi are located, and so this is where that synapse that will then go posteriorly to the cerebellum ends up. The one that comes all the way back here, this is where your visual cortex is, and then your visual association area. So that's why you have these different pathways coming back. This is why if you have a tumor in your parietal lobe, okay, it can affect your vision. Because back here is where you see, if you have something in the way here, it's not going to get back there. All right, does everybody see that? So that's why, anything that's going to be along the way of any of these tracks, that could end up causing issues. So that's why it passes through all those different lobes. Right, your depth perception, this is really important because this is your three-dimensional view. This is what allows you to see objects as they're coming in closer to you and you'll be able to make out what it is that you're looking at. And this is obviously really important in terms of driving. Okay, as you get older, you start to lose depth perception. In addition to then, your reflexes start to slow down. So it's really important that if you start noticing that, get your eyes checked. Right? It's very easily corrected. Then in terms of how the brain processes all this information, okay, it's going to come in, and then you're going to have synapses that take place in the temporal lobe, just above where the thalamus is, and then obviously your parietal, and then posteriorly. So all these things are all working together to help you process what it is that you're seeing. And it all has to do with, obviously, your life experience. Right, so that's it for the eyes.
Yay.
Okay? Then, chemical senses, right? Chemical senses, these are your chemoreceptors. Chemoreceptors receive chemicals. So this is going to be the stuff related to taste and the stuff related to smell. So chemoreceptors are one of the big keywords here. Okay? So your sense of smell has to do with these